Okay, so in the previous video we made a smear with solid media from S. aureus. Now we're going to make the gram stain. So the gram stain, it consists of staining the bacterial sample with two dyes, the primary dye, which is crystal violet, the secondary dye, which is safranin. So in order to stain your sample, you have to grab the edge where you identify your sample in the glass slide with the pin, clothespin. You put it here on this staining rack, and then you add crystal violet for 1 minute, the primary dye. So you will add enough to cover just the area where you have the smear, which is basically pretty much 2 to 3 drops. You count 1 minute after you added the crystal violet, so you put it back here, and then after 1 minute you will be rinsing with distilled water, and it's a kind of a soft rinse. You don't have to squirt so much water into there, because you will if you do that, if you're so forceful, one thing that it can happen is that the smear can lock off. I mean, although when we heat fix the sample here with the flame, it's supposed to adhere the bacteria and also kill the bacteria. So that's one of the advantages of using heat fix, that you kill and then you adhere the bacteria. And the next step will be consisting of adding a mordant or a fixative agent, which will create a bulk in the crystal violet. So this iodide, which is the mordant, will make this crystal violet to be a little bit bigger, so that one that will help for the crystal violet to not exit the cells as you're rinsing. This is S. aureus. This is a gram-positive bacteria. Gram-positive bacteria has a thick peptidoglycan layer. So now the minute has gone by. Look at how first I basically remove the excess of the dye before adding the rinsing, and then I angulate it this way, and then rinse as much as you can, even here in the back, and now you don't see as much crystal violet, or none. So then you put it back there, and also remove as much of water as you can, so that the next reagent, which is iodide, will go into there. And just as the crystal violet is 1 minute, and add 2 to 3 drops there to cover the sample. Close your reagent, and it goes in that order: crystal violet, iodide, and then it's going to be the decolorizing, which is alcohol, and then the last step will be the counter stain, which is the secondary stain, which is safranin. So again, when you add this iodide, you form a complex of crystal violet iodide, which is much bigger than the crystal violet itself. And at least if you have a sample of gram-positive, this crystal violet will stay all the way through the 4 steps of the gram. If you have a gram-negative, after the decolorizing step, since you create pores in the plasma membrane and in the cell wall of gram-negatives, crystal violet iodide complexes will exit, and then you need to add the counter stain, safranin, so that these cells will stain red. Now with the decolorizing agent, which is basically 90% ethanol, you will have also creating the gram-positives pores within the plasma membrane, but since the cell wall is very thick, it will dehydrate, and then it will cover those pores, so crystal violet will stay all the time in the cytoplasm. And then since you already have crystal violet in the cytoplasm, safranin won't come in. Now if you remember, or if you observe, the crystal violet is purple, so the purple color will stain all the way the gram positives, so they will stay purple. So now I'm going to check the excess of the iodide, and now I'm going to basically rinse off this iodide, shake off the excess of water, and now the next step is decolorizing with 90% ethanol. It is for 10 seconds. Sometimes you can have a mix of alcohol, 25%, and 75% acetone, which is in this case this reagent. So only 10 seconds, so you can decolorize the bacteria. If it's a gram negative, if it's a gram positive, you won't. So 10 seconds has gone by. This one you rinse as well with water. Shake off the excess of water and add the last agent, which is safrani, the counter stain. And similarly, just few drops to cover the sample. Let it sit for 1 minute. Rinse it off, let it dry, and observe under the microscope. In microbiology, we typically observe the microscopic samples at 100 times magnification objective lens, which is the immersion oil objective lens, the longest one. And you have to add immersion oil. One of the, I guess, the steps that is the longest in here is just waiting for this to dry. When you are going to have it to dry, it is not recommended. We have a kind of paper that is called bilirubin paper that you put on top, and then you can basically dab this paper on the top of the smear, but it's not recommended. So one of the things that we do sometimes is just tilt this slide to not be horizontal, to be vertical, so that way you have the water being rinsed off by gravity. So I think 1 minute has gone by. So you rinse off your slide really well, check off the excess of water, and you can just leave it in there and then wait till it's dry. This is all for this video.